Now here, as you can see, these are the equations. So we will first try to find with respect to yi the output. Li is this equation. So if you will just perform differentiation, we will get this log x differentiation 1 by x. So that only we are getting. Now we are going to find dy by dzi, because if you want to find dl by dv, so we are going to find dl by dv. So for that dl by dy, we want dy by dz, then dz by dv. So for those, then only we can chain rule, this thing. So dl by dv, so we can get dl by dv. So by chain rule, you can just cut like this and we will obtain dl by dv. So we want dy by dz. So we are just focusing on dl by dv for now. So in that dl by dv thing, first we need to find dl by dy, dy by dz, and then dz by dv. So dy by dz, we know that yi is softmax of zi, zi is this thing, k is the output classes. Now here we get two cases. Case 1, if I is equal to k, the k is nothing but the output class. We have 10 output class for suppose. Fifth one is the desired one. So if that belongs to k, that is I is that one. So what will happen? We need to find dy by dz. Case 2 is, if it is not, what will happen? What is the value of dy? It will be different, because it will be having the k is the actual output class, ground truth value, actual target label. So for that we will have different value, high value obviously if you will take in probability terms, and if it is not that case, and in that case loss will be less, because we have predicted that only. So we need to categorize into two cases that we will see now. So case 1, dy I hat means predicted with respect to dzk, that we will be having like this, e zi. So here you are basically applying UV differentiation or UV rule, VU dash minus V dash U. So this has U and this has V. So U differentiation with like E of X will be E of X itself, and this V is as it is. V dash we are doing, it is in the bottom, so we will get E of Zi whole square, we will get like this. And now then we'll just simplification, and this is nothing but yi of hat. So I will show you. Like yi hat is nothing but whatever we get output actually, right? So this one, softmax of zi, so this is totally this one, and we are just going to do yi minus yi whole square. We are just written in simplified form like this. So next we are going to see the case 2. So now in the case 2, where I is not equal to k, we will get the result as something like this. So if we just categorize dy by dz, case 1 I is equal to k, we will get this, as we have seen previously here, this thing. And for I not equal to k, this one, so we're just putting over here. So dl by dv, again we are just repeating with respect to all timestamps summation. So we are just categorizing this here, and we are keeping I. dl by dyi, then dyi by dz, and then dzi by dv. If I just want to show you again how it goes, so here, so with respect to y, then y with respect to z, then z internal we have v, so dz with respect to dv. So this is how the matching goes on in a chain rule fashion. So we in turn get dv by dl by dv, because this will be cancelled. So we have just found we need to find these values, and this whole which we have found now, dy by dz, we have found dl by dyi is this thing, y hat my yi by yi hat. So we are just keeping that over here, and the values which we have got, we are keeping it over here. Then simplification, we will get something like this. Here this will be cancelled out, and we will get yi into brackets 1 minus yi, and for this again it will be cancelled out. We will get y minus plus, it plus will happen. Here it's minus, and then we'll get y k hat. So whole in all, what happens is dl by dz hk is equal to yi minus of yi in minus minus plus yi hat plus summation of I not equal to k. For this is actually for I is equal to k. For all other i's yi yk hat. So for this is like I is equal to k, so we can write yik minus of yk plus yk hat. This thing I am talking about, plus I is not equal to k yk hat. So we can write something like this. Now we'll just see the simplification of this.